Hello everybody, welcome to another Python tutorial. This tutorial is going to be discussing how to calculate percent change. This is actually a highly debated topic amongst accountants and the like, so you know it's it's just going to be so awesome. So let's go ahead and get into it. The calculation of percent change, for the most part, is a relatively easy calculation, although not only do people disagree with the denominator at times, they also disagree with the conversion of that denominator at other times. So let's go ahead and just hop into it. The formula that we'll be using and that a lot of people use with percent change is new minus the old divided by the old times 100. Now you will find some people that are going to give you new minus the old divided by the new times 100. Now, what's the purpose for percent change? Well, generally, you have two major purposes for percent change that I see a lot. The first one is going to be to calculate some sort of profit, and so like you'll say like or growth, right? So if your new minus the old divided by the old times 100 will tell you how much growth you had in terms of where you came from to where you are now. So I think a good example for something like this would be like say you started at $80 and now you have $100. Well, 20 out of 80 is a quarter, right? So it's 25%. So from 80 to 100, you grew 25%, right? Because your starting point was 80. But some people want to say new minus the old divided by the new for percent change, and that would be really 20 out of 100. So really, they're saying you only grew 20%. I don't understand why you would do that, but that is how some people calculate it. That will not be how we're going to do that. It's going to be new minus the old divided by the old times 100. Now, the other thing that comes into question is when old is a negative number. So it comes into question a lot whenever companies, like a lot of companies, lose money for a quarter, and then the next quarter they gain money. And the question is, how do we calculate percent change of that? So I'll show you in a second how that affects things. Now, you wouldn't think that percent change is such a highly debated topic, but it actually is. So sorry to start the tutorial out with that, but I just have to make you aware that you might have to fight people on how you calculate percent change. Anyway, I'm a nerd. So, sample, we're just going to make a sample bit of data. We'll just make it just anything. You can type it with me or you can just make it up. 5, 6, 1, 3, 6, 3, 2. And let's throw some negatives in there. Negative 5, negative 19, negative 5 again, 2, 0, 1, 6. Cool. So that's just like some sample data. Now let's define a percent change function. So we're going to say define percent change, and then we're going to have two parameters. We're going to have the start point, so wherever the data starts, and then the current point. This brings me to another point. I only discussed the first reason people might use percent change. The second reason people might use percent change is to normalize a line. So like if you're comparing two, let's say, companies, you can compare them by percent growth instead of maybe revenue growth, right? So instead of comparing them by dollars, you can compare them by percent change. Then you can chart them on the exact same chart, and you can really compare them very easily. So that's another reason why people would use percent change. It's just a way to normalize a line, very simply. So percent change, start point to current point. What's the percent difference? So what we're going to do is have this function really only be one line, and it's going to return the float of whatever the current point is minus the start point. So this is new minus the old, right? And then we're going to go divided by the old, and we're going to throw some absolute value bars around it. So start point. Then when we're all done, we multiply it by 100. Now just for the record, we want to say float here, just in case. So here we're using all whole numbers, and Python does not naturally divide into a floating point decimal. It will automatically just divide into whole numbers if you don't start with some sort of floating point. So that's what we're doing. We're just kind of forcing it to use, typical division. So anyway, so new minus the new minus the old divided by the old times 100.00 again. Cool. So now what we want to do, now that we've defined this percent change function, we're just going to say for each n, for like each number in sample, PC for percent change equals percent change, and then where is our starting point, right? The first parameter is start point. Well, that's easy. That's sample 0. And where is the current point? Well, each n. And then when we're all done, let's go ahead and do this. We'll print each n, and then we'll print like these little bars here so we can divide it or see like the difference, and then PC. So cool. So let's save that and let's go ahead and run that and like look at the output. So here's the output that we've got. So obviously the first number, there's no percent change, right? from 5 to 5, and then from 5 to 6, you've got a 20% change. From 5 to 1, you've got a negative 80% change. From 5 to 3, negative 40% change, and so on. Now the next question is, what was I talking about before with the absolute value? So let's just take away the absolute value. So it'll be pasted right below this one, so it won't really matter. So let's take away the absolute value and see what happens. You'll see there's no change. And there's no change because this did not, the 5, right? The 5 that we're dividing by. So what happens is when you divide by a negative, what mathematics does. But when you go from 5 to all of these numbers, including a negative, it computes the negative correctly. But let's say you actually went from let's make 5 a negative 5. Let's return the absolute value for now. Let's run that, and let's see. So we started from negative 5, and we went to 6. I would call that a positive movement, and I assume you guys would too. And we are indeed returned a positive 220%. Then as we kind of decline a little bit to 5, now it's only a 120%. Now we go back up to 3, 160, 6, 220, blah, 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 blah. Then we get to negative 5, no doubt a 0% change. Negative 19, well, now we've actually lost, and we actually have a negative. Okay, I think you guys get it. So now let's take away the absolute value bars and do the typical percent change calculation. Now we can see from a negative 5 to a positive 6, we have a quote-unquote negative 220% movement, as if we lost something. Then we get, to negative 19, and suddenly we've got a positive change, right? So this is kind of why it matters what your actual goal is, right? So if you wanted to make the movement from a negative 5 to a 6, in theory, you could get there by doing negative 5 minus a negative number, and that would give you a plus, and you could move forward. And so you can kind of see how this negative 220 is appearing. But at the same time, that's not actually the result that we're looking for, especially if we're either looking to measure growth or even decline, right? So from a negative 5 to a negative 19, that would be called a decline, right? Or really, I guess this would be fine if you were measuring decline, right? You had 280% change in your decline or growth in your decline. But if you're trying to measure growth, really this was a backwards movement, right? From negative 5 to negative 19. This should be a negative. And then same thing if you're trying to normalize lines and compare two different lines. Gosh, if one line is starting with a negative 5 or a negative at all, you're in trouble. You're going to have a really hard time normalizing the lines. So that's why I throw in the absolute values there. It just makes more sense to me logically. So every time I've ever used a percent change, I'm actually looking either to normalize a line or either normalize for comparison or actually measure some sort of growth. So that's why I think you should throw in the absolute value bars. Anyway, something tells me no one else is going to care that I did that, but felt like I better defend it. So anyways, hopefully you guys learned something new. As always, thanks for watching, thanks for the support and the subscriptions, and until next time.